Hey everyone, in this video we're going to be taking a look at how to find critical numbers. So a critical number of a function is anywhere the derivative of the function is equal to 0 or it's undefined. A critical number, they give us all the possibilities of where we may have local extrema, so local minimums or local maximums. If the derivative of the function is equal to 0, that means that the slope of the tangent line is 0. That is a local max or a local min. If our derivative is undefined, that means we have a vertical tangent line, and that can also give us a critical number. So I just want to talk through how to do this. So in my first example, I have a function f of x is equal to x cubed minus 6x squared plus 9x plus 2, and I want to find all the critical numbers. So the first step is we're going to find the derivative of this function. So let's find f prime of x. In this case, this is just a polynomial, so we can just use our power rule. The derivative of x cubed is 3x squared. The derivative of 6x squared, the 2 comes down, so 6 times 2, we get 12x. And then the derivative of 9x, this is plus 9. The derivative of 2 is just 0. So now to find our critical numbers, we're going to take our derivative and we're going to set it equal to 0. So we have 0 is equal to our derivative. So in this case, because we are just dealing with a polynomial, we don't have to worry about the undefined cases. We don't have anything that would make this derivative undefined, so we only have to find where that's equal to 0. I'm going to start by dividing everything by 3. I see we have a common factor of 3 in all these terms, so let's divide everything by 3 to make it a little bit easier to work with. So we get 0 is equal to x squared. If we divide by 3, we get minus 4x plus 3. Now we can factor this. So two numbers that multiply to 3 add to negative 4, we get x minus 1 and x minus 3. And now setting both of these binomials equal to 0, either x minus 1 is 0 or x minus 3 is 0. So our two critical numbers, we have either x is 1 or x is equal to 3. So those are our two possibilities for local extrema. So one of these may be a local maximum, one may be a local minimum, or they might both be maxes or mins as well. So the other important thing that we do need to check whenever we're looking at critical numbers is the critical number has to be in the domain of our function. Well, as I said, this is just a polynomial. The domain of this is all real numbers, so both of these are in the domain. So these are our two critical numbers. Let's try one more example, a little bit more complicated. So I have a function g of x, and this is equal to x minus 2 raised to the 2/3 power divided by x. And I want to find the critical numbers. So again, let's start by finding the derivative. In this case, we're going to need to use the quotient rule. So our quotient rule, we have our denominator times the derivative of the numerator. So finding the derivative of the numerator, we can use our power rule for functions. So the 2/3 will come down, and then we'll subtract 1. So 2/3 minus 1 is negative 1/3. And then we multiply by the derivative of the inside, but that derivative is just 1. And then we have minus, so now we have our numerator times the derivative of the denominator, and the derivative of x is just 1. And this is all divided by our denominator squared. Okay, so here's our derivative. It's a little messy right now, but we can actually break this up and we can find our critical numbers. So you have a couple possibilities, remember. So either our derivative has to be equal to 0 or it has to be undefined. So right away there is one value that will make this undefined, and that is if x is 0. So over here I'm just going to start listing off my critical numbers. So one of them, x is equal to 0. Okay, now to find when this is equal to 0, I only have to worry about when the numerator is going to be 0. So let's take the numerator, we'll set this equal to 0, and we'll work with this a little bit to see what we end up with. So now the first thing, before I even rearrange this or simplify it all, one of the things that I do notice is I'm going to have a critical number at x is equal to 2. If I plug in 2, 2 minus 2 gives me 0. Doesn't matter what the exponent is, 0 raised to any power is 0. So this will become 0. This term will also become 0. So 0 minus 0, so we end up with another critical number at x is equal to 2. Now let's go through and we'll try and solve for x. So the first thing I'm going to do is I just want to clean this up a bit, do a little bit of rearranging. So in our first term, we have a negative exponent, so I'm going to move that down into the denominator. So let me rewrite this as 2x over 3 times x minus 2 to the 1/3. And then we have minus x minus 2 to the 2/3. All right, I'm going to take the second term, I'm going to add that to both sides of my equation. So that's going to give me x minus 2 to the 2/3 is equal to 2x over 3 times x minus 2 to the 1/3. All right, now the next step, I'm going to multiply both sides by the denominator. So we're going to multiply by 3 times x minus 2 to the 1/3 on both sides. Now on this left-hand side, when I do this multiplication, I have x minus 2 to the 1/3 and I have x minus 2 to the 2/3. Our shortcut for multiplying, they have the same base, different exponents, we're going to add these exponents together. So 1/3 plus 2/3, that gives me 3 over 3, which just simplifies to 1. So this whole thing, the exponent becomes 1, so what I end up with, I just end up with 3 times x minus 2 to the 1st. And then on the other side of the equal sign, we have our 2x. So that cleaned up really nice, and we can solve for x. So distributing the 3, we get 3x minus 6. If I subtract 2x from both sides, we get x minus 6 is equal to 0, and we get x is equal to 6. So here is another critical number. X is equal to 6. And as I mentioned in the first example, we do want to double check to see that these are in our domain. This first one, x is equal to 0, 0 is actually not in our domain. It's excluded because in our original function, if we plug in 0, we would end up with something undefined. So this one is not a critical number. But 2 and 6 are both in the domain of this function. So that means our two critical numbers are x is equal to 2 and x is equal to 6. So again, just to summarize, critical numbers, they give us the possibilities for any local extrema. So we find the derivative, we set the derivative equal to 0, and then we need to find where's the derivative 0 or where is it undefined.